Lastly, we have to consider mathematical operations and significant figures. First, we'll consider addition and subtraction. This is good because these are relatively easily handled. We are going to report our final value based upon the lowest accuracy of our inputs. We are not going to report our final value based upon the lowest number of significant digits. For example, if we take 12.5 inches and add it to 12.25 inches, we would have a value of 24.75 inches. Now, we might be tempted to report this to 3 significant digits. However, although our answer does have 3 significant digits, we are going to use our lowest accuracy input to determine our output. Our lowest accuracy input is dictated by the tenths place. That is, 12.5 has our lowest accuracy, because 12.25 has a digit in the hundredths place. So our answer has to be reported in the tenths place. That is, we are going to report 24.8. We'd look at our tenths place and round it, since we have 5 to the right. It's a coincidence that we had 3 significant digits in our final answer, and we had 3 significant digits in our input that is determining the lowest accuracy of our solution. Now, to further consider this, let's assume we are adding 70 meters to 300 meters to 240 meters, and we'd have a result of 610 meters. But we see here that our lowest accuracy is dictated by the hundredths place of 300 meters. That is to say, our answer would be reported as 600 meters. That is, we are going to have one significant figure in the hundredths place. Now, when we consider multiplication and division, we are going to report our answer in terms of the least number of significant digits of our input. This differs than what we did for addition and subtraction. For example, imagine we have a 98.5 Newton force acting on a 0.5 by 0.5 meter plate, and we want to report our pressure in the proper number of significant digits. For us to do this, we'll recall pressure is force per area. Our force was 98.5 newtons, and our area is 0.5 meters times 0.5 meters. We would conceivably report our answer as 394 Pascal. But recalling our output is limited by the least significant digit of our input, which is 1, as expressed by 0.5 meters, we would express our pressure then as 400 Pascal.